Welcome back. Today we are targeting M51, the Whirlpool Galaxy. To capture those fine details, we're using our 1000mm 8-inch Newtonian for a requested showdown. Old tag versus new tag. We're pitting the big pixels of our trusty Canon EOS 600DA against the small modern pixels of the ZWO 585 MC Pro. We're still beginners on this journey, but we like to take you along, so let's see which camera comes out on top.
Finding M51 is a breeze since it's positioned right near the Big Dipper. In fact, in the vicinity of the Big Dipper and M51 there are a lot of other galaxies to discover. We started our night with the 8-inch 1000mm telescope and the trusty Canon EOS 600DA. Because of the Canon's APS-C sensor, we get a beautiful spacious wide field of view. The Canon's 4.3 micron pixels are comparably big and don't resolve as much fine detail as the ZWO. With just a 10-second test exposure, you can already make out the core. Pumping that up to 45 seconds revealed significantly more. The guiding was not ideal, but we were unclear of the reasons. The before and after the stacking shows the benefit of using ZWO software. The stacked results after about 2.5 hours of total integration time, shot entirely from our backyard under Bortle 6 skies, is pleasing, even if the galactic core appears slightly blown out and lacks a bit of details.
Before we jump into the main comparison, we run a quick little experiment. We wanted to see what happens if we pair the smaller modern pixels of our cool ZWO ASI 585 MC Pro with a smaller 6-inch 520mm Newtonian. Would it resolve similar details?
A single 60-second exposure already showed similar detail, clearly thanks to the smaller pixels of just 2.9 microns. Unfortunately, we only managed to grab 1 hour of integration time before the bad weather rolled in again. So what do you think? Was the setup worth the effort? Back to the main event, our showdown of old tech versus new tech. Switching the ZWO camera over to the 8-inch telescope, you immediately notice the difference the sensor size makes. Because the ZWO has a much smaller sensor, the Whirlpool Galaxy fills the frame beautifully. We kept the same framing as before, and as you can see, the Galaxy is now very close to the edge of the image. One thing we love about this modern camera is the low latency and high frame rate. It makes the entire focusing process incredibly relaxed and fast, and we didn't even need to use a Bahtinov mask. If you think a Bahtinov is a must, just let us know in the comments. After 1.5 hours of exposures, the ZWO delivered a massively improved result, and any potential issues with the optical tube completely faded into the background. Looked fantastic, however the framing just wasn't exactly what I had in mind. So we decided to give it another go a few nights later. The catch, we were shooting right into an 80% illuminated moon. We started with what the sensor sees in 1 second, not more than the core, but with 10 seconds you can see the arms, and with 30 seconds you get an idea of what the final image will look like. We managed to gather a lot more data, about 3 hours, and combined with the heavy light pollution, the final image shows the galaxy in the dust lanes really well. The background just didn't look that great. Thankfully, a few nights after that we started the process one final time, but then plate solving failed for some unknown reason a few times with the air meaning. It took us a few times until it worked, and we don't know why. And with just our usual city light pollution, we finally managed to get our best results yet. The details are much better as the auto guiding worked fine.
We'd love to hear your thoughts. Do you think more integration time on the Canon could actually beat the cool ZWO? Let us know in the comments below. And don't forget to like and subscribe, please.